Introduction to Computers and Information Systems. Alright, we are going to talk about software today. Just a little review of where we've been at. We have talked about a little bit about the actual equipment, the hardware, and now we're going to talk a little more specifically about the instructions. Somebody writing some type of code to get the computer to solve a particular problem or do a particular task, like play a game or do some work on a spreadsheet, word processor. People are involved with this also. We've already covered this, trying to become a little bit more than just using technology, but a little more of an expert, and then how computers communicate. So we should know bits and bytes. Bits are what actually the computer deals with, ones and zeros. And we've talked about they represent raw facts. Software then can take those raw facts and organize it into valuable information, or maybe not so valuable information. We input, we process what is input, and we get some type of output. We save the data. Data is converted or processed into information, organized facts. Now, we do that, and nowadays we want to be able to move that around. So we talk about networks in the same geographical area and wide area networks that use a service provider, somebody to get our data from one location to another. We gave some examples. The information and data, I should say, can move across wires, in the air, through a couple different methods in the air, and by light through fiber optics. This is the biggest thing we share. We can also share equipment through networks, and we can also share software through networks. And the internet allows us to connect networks. The internetwork allows us to connect it. And we talked about these right here, items. And we spent a fair amount of time talking about storage. Now we're going to talk about software. Software is developed by people. People write software. You can get very good software, you can get bad software. Viruses are software that tell the computer to do things we don't want the computer to do. Virus is a piece of software. Somebody writes it. They write the code, they compile it, they figure out a way to get it into your computer. Usually due to a lack of being aware or clicking somewhere as you shouldn't, or not having software to identify viruses when they come inside your computer. Software is the key element making technology work. There's a great example of coding at code.org, and we'll look at that more later on. Two basic types of software. We have system software that deals directly with the hardware, and we'll diagram that out. That's divided into two parts: the operating system and utility software. Utility software we demoed earlier on, like some type of file management software. That would be an example where you create folders and so forth. That would be a utility software that helps you communicate to the operating system. The operating system works directly with the hardware. The operating system works directly with the hardware. All computing devices need some type of operating system. Now, we've heard of lots of operating systems. For example, iOS, which is in your iPhones and iPads. Android, which is in certain types of smartphones. Windows, Windows XP, Windows 7, Windows 8 by Microsoft, those are all operating systems. Mac OS, in the Macintosh world of computers, that's an operating system. And then Unix and Linux would be an operating system. So we have lots of different operating systems. They all communicate with the hardware. They get the information from the memory to the processor, from the memory stored out on the hard drive. They do all that work. They allow us to run multiple programs at the same time and be processing those things at the same time. You can be downloading things from the internet and you can be reading your email. Now, application software communicates with the system software. So you get an application software, for example, Microsoft Office, that communicates with Microsoft Windows in order to function. Okay? So the application software communicates with the system software, which then communicates with the hardware. Application software, we have two areas. We have horizontal and we have vertical software. Horizontal would be things like Microsoft Office. Okay, it works across a variety of industries. Lots of people can use Microsoft Office. Vertical software is geared more towards one industry. For example, WebAdvisor. Here at the college, that's geared to the industry of education. That's a vertical software. It's geared to the industry of education. So it's like a silo. It's just deals with education. Okay? A lot of custom software. Companies have software designed to do specific things. Okay? It's vertical. For example, in the retail industry, we have point of sale software that allows us to check out. Okay? Now, that could be retail or any place that sells item. That's like a vertical. It's designed to do a specific task. So you could use it in Hy-Vee. It wouldn't be just retail. But it's in an industry that's designed, well, Hy-Vee, their checkout software would be a little different than a retail store probably. Okay, it would be geared more towards the grocery industry. Okay, software can be the location of software. Software can be on your device, so you run it right on your device. Or you could be in an environment where the software could come off the server. For example, here at the college, the software could come from, that you're using, could come off a server and then into your device through the network. Some places run Microsoft Office that way. The advantage to that is they only need to maintain this piece of software, okay, and lots of people can use it. In fact, that's becoming very popular in something known as thin client. You have a PC that has very little resources, a small hard drive, but it gets all of its resources from somewhere else. Either a server, a local server, or we can run software from the cloud. We can run applications and software right from the cloud. This would be more like, I suppose, Google Docs would be considered running from a cloud-based application. So where the software is important to understand. We'll talk about that as we move along. Okay, almost done with this part. Here's just some examples. I just list some examples right here. Email is a piece of software. Your browser is a piece of software. Probably runs locally. That would be running right on your device. Email, that could be running like from a server or, actually through your browser. Gaming, we all know we can run some gaming out of the cloud. Maybe we all don't know that. Or you can have a game right on your Xbox. Your Xbox is a computing device. That's no different than a lot of technology. You have software that plays music. You might have your iPod that plays music. That's a little computing device that has some type of software that plays the music. If you're running video on your computer or your device, there has to be some software running that. And then if you're going to be doing word processing, there's got to be software that allows you to do that. Okay, everything we do on the computer is run by some software. Now, the last thing in terminology we want to talk about is the difference between proprietary software and open source software. Okay, I'm going to define that a little bit more on the next page, but proprietary is software that we actually lease or use, or it appears you're buying it, but like Microsoft, most of their software is proprietary. They own it, they coded it, they compiled it, and we can use it, pay money to use it, but we can't change it or adjust it, basically. They own it. Adobe sells all kinds of proprietary type software, sells us licenses to use it. You know, you could go down the list of all the different ones. Open source is software that the source code in which the software was written is open. People are allowed to look at it, change it, and adjust it. And most open source licenses allow us to have the software and not have to pay for it. It's open. People can just use it, change it, and adjust it. We will talk a lot about these during the term as we go along. It's important to understand the difference. All right. So here's what happens. We have hardware, maybe a hard drive. We have memory. Now everything has to move through here. So if you have some software, it gets loaded in the memory, and then you have some data, and data gets loaded in the memory. Then we have an electronic bus in here. And information moves from memory. Maybe this is the processor, can move back and forth there, and we can compute. Okay? What makes this all work in here, what makes that all work, is the operating system. So the operating system deals directly with the hardware. Okay? And then what we have then are applications that deal with the operating system. They deal with the OS. And then we have people, users, that deal with the app. And then we can have experts who probably know how to deal not only with the app, but they can deal a little bit with the OS, like create files and directories and those things, which you should already be able to do. The last thing we'll mention, software, people write code. It's called the source code. The source code then is converted into executable code. And that's what executes on the hardware. Whether they're operating systems, any software goes through this process. We'll go through the details towards the end of the course. That's why they call it open source or proprietary. That's it.